Hello everyone, my name is Aarohi and welcome back to my channel. So guys, till now we have studied about theoretical and mathematical part of LLMs and transformers. And today we will start with the practical implementation, and in my today's lecture I will show you how you can train your own tokenizer on a domain specific data. Means I will first show you how to collect data from internet, and once we collect data from internet we will clean that data, then we will train our tokenizer on it, and then I'll show you all the tokens which our tokenizer created. Because if you remember, in my previous lectures I have explained you that your LLM or transformer, when it predicts the next word, it predict that next word on the basis of the vocabulary which your tokenizer created. So that vocabulary we will create today out of the dataset, out of the raw text which we will collect from the internet. So guys, before we start our practical implementation, I want to clear a few things about tokenizer and then we will start the practical implementation. So we know, why do we need tokenizer? We need tokenizer because our AI models, they don't understand the text, they only understand numbers. So with the help of tokenizer, we will first divide our input sentence into tokens, and then tokenizer will provide unique ID to each number, and these numbers then we can pass on to our transformer or our LLM for further work. That's why we need tokenizer. Now there are different type of tokenizers. Okay, some tokenizers, they tokenize the text on the basis of entire word. Means for one word will be one token. And there are some tokenizers which tokenize the text, which tokenize the words into subwords. Means you will get tokens, but instead of getting the entire word as token, that word will be divided into two or three parts, and that subword will be one token. Now let's discuss when to use which tokenizer and which tokenizer is best for your use case. So the first problem is vocabulary explosion. What is this vocabulary explosion? Let's discuss that. Right now we are discussing about word level tokenization. Means we are talking about the tokenizers which create one token for one word. So for example, if we have this sentence, my name is Aarohi and I love coding, here you will note that my is single word. So this will be a one token, and this is the token ID. This is the unique ID which we got for this token. Then name is another word. So this entire word is one token, and this is the token ID of it. Then is Aarohi and I love coding. So we have one word, and for all these words we have one ID. So this is called word level tokenization, where each word is a token. We are not dividing the word into two or three parts. Now what is the problem with this kind of tokenization? The problem is vocabulary explosion. Now let's understand what is this vocabulary explosion. So guys, just think of real language. In real language, we have millions of words. Even for single word, we have multiple words. So for example, for run word, we have different tenses: ran, running, runs, right? And then we have lots of names, unique names, and every day new words are getting invented. So just see that we have millions of words in our real language. And if you give all those millions of words as a vocabulary to your LLM, then what will happen? First, your LLM will need more memory to handle all those words, right? Then the resources which you will use for training, that you also need more, because to handle such large data set you need more resources, right? Then training will be slow, and your model will also take lot of time to generalize. So this problem is called vocabulary explosion, where you have lot of vocabulary which you give to your model. So this is one problem. Now there is one more problem when you work with word level tokenization. Let's discuss that. So the next problem is this out of vocabulary problem. Now suppose this is your vocabulary. For now, just imagine that this is the vocabulary of your LLM. These unique words your LLM know, And vocabulary simply means that when your model will predict the next word, it will pick any one token from here, token from this vocabulary. Okay. And now let's say this is the vocabulary of your LLM. And this is the input you gave to your tokenizer. Once your LLM is trained, after that, this is the input which you gave to your LLM. And over here, we have my name is Aarohi and I write code. Okay, this is our input sentence. Now, if you will note that this write token is not present in our vocabulary. We have writes, we have writing, but we don't have write. So, when your LLM will work on it, when your tokenizer will work on it, so your tokenizer will write UNK, this tag. This means unknown token. Why your tokenizer will write unknown tag over here? Because your tokenizer don't know about this write token, because this write token is not present in the vocabulary of the tokenizer. Means with word level tokenization, you need to provide lot of words to your tokenizer, and even we have similar words, even we have this writes and writing, still your tokenizer will not know what is this write, because that particular word is not present in the vocabulary. So this is the problem which we face when we use word level tokenizers. So what are the two problems? So the first problem is this vocabulary explosion, and the second problem is this out of vocabulary problem. Now we can solve this problem with the help of subword tokenization. Now let me show you that. Subword tokenization simply means that one word will be divided into two parts or three parts. Let me show you how. So for example, this is the vocabulary. Okay, this is the vocabulary, and this is the input sentence which we gave to the tokenizer. But this subword level tokenization, what it does, see, it divided the write into two parts, WRI as one token, TE as one token, then writing, write as one token, ing as one token, and S as one token, then code as like this. So when you use subword tokenization, this method, in this case, your input, my name is Aarohi and I write code. See what we got. My name is Aarohi and I write WRI, this token from here, TE from here. Earlier, when we used word level tokenization, we were getting unknown tag over here. See, we were getting unknown token over here, right? But when we use subword level tokenization, that problem is solved. We got the tokens over here also. So guys, what is the benefit of this subword level tokenization? The first benefit is that you will not face the problem of which problem? The problems which we discussed above. Out of vocabulary problem, right? You will not face this problem. Over here, when we use word level tokenization, we face this unknown token problem. But when we used sub word level tokenization, even though this right word is not present in our vocabulary, still we got right token over here because we used subword level tokenization. This is the one benefit. Another benefit is, see the first point which we discussed. What was the first point? Vocabulary explosion. This simply means lots of tokens you are giving to your model at the time of training. And this problem is also solved because now instead of giving lot of different tokens to your model, we divided our tokens into sub tokens, and that way you are giving less tokens for training to your model. So this is the benefit of using subword level tokenization. Now guys, I'll show you practically how to collect data from internet, right? We will collect raw text from internet, and then we will use subword level tokenizer. I will show you how to use BPE, byte pair encoding. This kind of tokenizer OpenAI use for their GPT models. So today I'll show you end to end how you can train your own tokenizer based on your use case, means domain specific tokenizer we are going to create now. So let's start. So let me open VS Code. First, let me show you what all packages you need to install. So guys, I have created a separate environment for this tutorial. So let me activate that environment. So this is my environment name, and this is how you activate the environment. And let me show you the Python version which I'm using. So this is my Python version. And now let me show you what all packages you need to install to run the tokenizer. So these are the packages you need to install: request, beautiful soup 4, and tokenizer. Why we need this request package? Because we want to get the data from internet. So domain specific data from internet. For that we need this module. Beautiful soup 4 package we need because when you will want to get the data from the websites, so beautiful soup will help you to get the to extract the data from there. And then this tokenizers package, this package is developed by the Hugging Face, and using this package we will use the tokenizer. So we need these 3 packages. In my case it is already installed, but I will run it for you. And if you're running it for the first time, you will get all the packages installed. So that's it guys, this is the only requirement. And now let's create one folder. So what we are doing is, in my E drive, okay, so in my E drive I have LLM tutorials folder. Inside that folder I have created one folder with the name of demo, and we are going to work inside it. So let's create one file over here, Python file over here. Just click here and name it data collection dot py. In this file we are going to write all the code related to collecting data from internet. So first we are importing all the packages. We are importing the requests package because we want to get the data from web pages. And then we are using this beautiful soup package. Why? Because we want to extract the data from the pages of the websites. And guys, then we have these URLs. So basically what I'm doing is, I want to collect data related to artificial intelligence, machine learning, deep learning, and generative AI. So basically today we are going to build a tokenizer which works well with topics related to AI. So that's why I gave the link of these pages from Wikipedia. Okay, so these are the URLs from where we want to scrap the data and then we want to use it. After providing the URLs, we will write this script. What we are doing here, let me explain you. So corpus, we have created one blank list. Here we are going to store the data which we extract from these pages. And we are using a for loop. We will visit all these URLs one by one and we will get the data from there. And then we are using beautiful soup on it because see, on web pages there are lots of tags, HTML tags. So we just want to get the data which is useful to us. So that's why we are using this beautiful soup. It will get us the data. And then in this loop we have another loop. This loop will get us the data, and then we are appending the corpus list, this corpus list, with the text which we got from there. Okay, and then we are just printing. I'm just showing you how many different samples we collected from these many different pages. So let's save it and run it. So we need to enter into the demo folder, right? Because our code, this code is in demo folder. So I entered in that folder. Now run Python and the file name is data collection.py. See, total text samples collected 488. What does this mean? This means that there are 488 different paragraphs or pages we collected from these different pages. Now let's save all the data, all the text, all the different 488 paragraphs which we got from these pages into a text file. That text file then we will pass to the tokenizer. So to save this data into a text file, you will write this script, this much part. See, I want to create one file with the name of AI underscore corpus.txt, and we are providing the list, this list which have 488 different paragraphs in it, and then we are writing all those lines in this file, and you will see the this file in this directory only, demo directory only. So let's save it and run this file again. See, we have these many records. Now you can see AI corpus.txt file in the demo folder. Let's open it and see it. Okay, let me open it from here. See, in LLM tutorials, this is the demo folder. Click on it. This is the AI corpus.txt file. Let's open it. See, this is the text file you got. And guys, if you'll note here that you are seeing the citation numbers, punctuation is here, right? So now we will perform one more step. That step will remove these citation numbers because we don't need these citation numbers. So this is the extra content in our text file. So we will delete this part. But guys, we will not delete any punctuation. Why? Because in Tokenizer, when you train your Tokenizer, we train about punctuation also, because punctuation tells your Tokenizer about the sequence boundaries, how the words are related, right? So punctuation we will not remove. We will only remove these citations number. So let's write a code for this part. So go to your VS Code here. So below this, here I'm writing. So I created this function. I'm importing this package, and then I created one function with the name of clean text. So this line will remove this kind of text from our text file. And then we have this line. This line will simply put the white spaces. So that's it, guys. This is the only function we are writing. Now let's perform this step again. Which step? Just have one blank list, then run this part, and then save it in our text file. This same code we will write again, because this time we want to use this function with the above script. So that is what I'm doing now. I created one list. This time I gave it a name, cleaned corpus. Then we are running a loop on it. Then we are seeing how many samples we have. And then I'm creating a new text file. This time the file name is AI corpus cleaned.txt. Save it and run. So after cleaning, we got 486 sample, and on this side inside demo, this time you can see AI corpus cleaned.txt. Now we will open this file and we will see that if these kind of text, if these kind of values are still there in our text file or not. So let's open this file. So we will open it from here only. See, let's open it. See, you can see we don't have any citation numbers right now. Earlier over here we have, see, this is the earlier file, right? We have these kind of numbers over here, but after cleaning we don't have those kind of numbers, citation numbers. So our file is ready. This AI corpus clean.txt will be the input to the tokenizer. Now let me show you how to train your tokenizer on this domain specific data, and our domain specific data is related to AI. So we will provide this data to the tokenizer. Now let's do that. So for that, create one new file and name it train tokenizer domain specific .py. So here we will write the code for tokenizer. And guys, I've told you that we are using which package for tokenizer? Tokenizer package from Hugging Face. And now we will import that. So see, from tokenizer package, I'm importing tokenizer. Then from tokenizer.model, I'm importing which model? Which tokenizer algorithm we want to use? BPE. byte pair encoding. And I've told you that this tokenizer is getting used by GPT models also. So we are using that on to train the this tokenizer, right? PP tokenizer. So for that, we are taking BPE trainer from tokenizer.trainer, and then we are using this pre-tokenizers. From this pre-tokenizers, we are importing the white space. What does this mean? This simply means that before giving the raw text to the tokenizer, we will put white spaces between the words. After that, here we in this variable, we are using this BPE tokenizer, and we are defining this also. What this means, UNK, guys, I've already told you that this means unknown token. This simply means that when your tokenizer will work, and suppose user gave input, and in that input there is some word which is not present in the vocabulary of the tokenizer, then tokenizer will put this unknown tag at the place of that word which is not there in the vocabulary of the tokenizer. Okay, so we will understand this in detail. I'll show you practically where you will see this kind of output. And then this part I have already told you. Pre-tokenizer white space means that before giving the text to the tokenizer, we will put white spaces. After this, let's create a BPE trainer, because we want to train this tokenizer on our dataset. So let's do that. So I'm creating a trainer and I'm telling it that use BPE trainer, vocabulary size is 5,000. That means the tokenizer which we are going to create, this tokenizer will create 5,000 unique words. Minimum frequency is 2, and then special tokens. You know about this token, unknown token. If the word or token is there which is not in the vocabulary of the tokenizer, then tokenizer will put this tag at the place of it. Padding, this is a padding tag. Padding simply means sometimes the sequences are short, then using this tag we will pad the sequence. Then BOF is beginning of sentence, EOS is end of sentence. So why we need these kind of tags, beginning of sentence and end of sentence? Because this will teach the model to know the boundary of the sentence. Means it will teach the model from here the line is starting and this is how the line is ending, those kind of things. So from here we know that once we train the BPE trainer on our dataset, it will give us 5,000 vocabulary, 5,000 unique tokens. And later on, when you will use this tokenizer with your LLM or transformer, then your transformer or LLM will generate the next word, will predict the next word, and that next word will take from these 5,000 tokens only. Okay, so now we will provide our text file to it. So this is our text file. We are saying that tokenizer.train, on which file we want to train it? On AI corpus. Okay, so our cleaned file is AI corpus cleaned. We will give the name of that file AI corpus cleaned.txt, and we want to train the tokenizer. That's it, guys. With this much of code, you can train your tokenizer. Okay, so save it. This will train the tokenizer, and once your tokenizer is trained, you want to save those tokens, those vocabulary, 5,000 vocabulary somewhere. So for that, you will write this line. So this line will create a JSON file, and when you will open that JSON file, you will see the 5,000 vocabulary, unique vocabulary. Okay, so save it. So let's run it. Python, then the file name is train domain specific.py, enter. See, our tokenizer is trained, and here you will see a JSON file, AI Subword tokenizer.json. Let's open this file now. From here, let's open it. So where is a JSON file? This is the JSON file. We are opening it now. See, this is the file. First, this is just a version, leave it. And then the tokens which we added. Remember, we added unknown token, padding token, beginning of sentence, end of sentence, right? These tokens we added ourselves. So unknown token have id 0, padding token has id 1. Like this you can see all the tokens. And guys, remember I've told you that we are using pre-tokenizer white space. It is mentioned over here. And now this is the important part. Model. Which model we are using? BPE, byte pair encoding model. We are using, this is the tokenizer. And then here we are saying whenever your tokenizer doesn't find a word, then it will fill unknown token at the place of it. Then vocab. So this is the vocabulary, guys. From here you can see the vocabulary. So unk, this tag, we have 0 over here. We mapped this with 0. What it means, that this means that wherever you will see 0 in the output, that means it is unknown token. Wherever you will see 1 means that token over there you provided, you added a padding. And 2 means beginning of the sentence, 3 means end of the sentence, like this. Then we have symbols. For each symbol we have a number. Wherever you see 5, it means this symbol. Wherever you see 6 in your output, that means this number. Like this, you have the punctuation which is there in your raw text. These are the IDs provided to it. And then we have 0 to 9, right? So for these are the IDs. Then we have ABC, capital ABC till Z. 50 is the ID provided to S, 49 is the ID provided to R. So why? See, whenever you will use this BPE tokenizer will always provide the IDs to all the alphabets also, so that it can handle all the alphabets which are there in your text file. And after that, we have small abc. Then we have symbols, because we have symbols in our punctuation. We have symbols in our raw text file. And guys, see, then we have in, th, er, at, on, an, these kind of words, subwords, right? So from here you can see that your subword tokenizer is working. And these are these subwords are very common. The, like, in, you can see this in many of the words. Like this, we have these common subwords. Scroll down, then you will see more subwords. See, lear. Then learn, we have a separate subword. Then learning we have. Then are, know, were, words, like this. These are the subwords. Keep on scrolling. So this is our vocabulary. Keep on scrolling, guys. And then see, then you are getting, see, intelligence, artificial. These kind of words are not getting divided into subwords. Why? Because these words appear frequently in our text file, because our domain specific data is about artificial intelligence. So this tokenizer, it didn't broke these words into subwords, because these words are appearing very frequently, and tokenizer learned that these are the single words. Okay, so artificial intelligence, method, develop, these kind of words are there. Keep on scrolling. See, maybe we have recognition over here, and it divided into subwords. And like this you can see algorithms. See, algorithms, we have full word. And then keep on scrolling and see. So this is the vocabulary which our tokenizer created. And when you will use this tokenizer with your LLM will pick any of the word from this vocabulary only, and it will use that word as a next word based on the probability value. So all these words which are there in our vocabulary will get one probability value. The token which will have the highest probability value will be the next word generated by the LLM. So this is how you create tokenizer. This is how you train tokenizer. See guys, here we haven't used any heavy training. We haven't trained the model for lots of epochs. We are not using any kind of GPU. We just wrote this simple script and our tokenizer is ready. And guys, why we are not doing any kind of training? Why there are no epochs? Because here model is not learning anything. Your tokenizer is not learning anything, right? It is not learning the relationship between the words. It is not learning the semantic meaning. Here tokenizer is just learning how to divide the words as a token. So that's why we don't need any neural network over here. So now let's test this tokenizer. We will give it a input, and in that input I will add one word which word is not present in the vocabulary, and we will see if that word is getting handled properly by the tokenizer or it shows us unknown token, because we have mentioned in our script that if tokenizer doesn't know the word, then it will put the unknown token at the place. And let's give it an input. So let's write an input over here only. So this is my sentence. Agentic AI system use generative model for autonomous decision making. So this agentic, this is not present in our vocabulary. We will see how this word gets handled. Okay. And then tokenizer dot encode. So this is how you will encode the input which you will give to the LLM. Tokenizer dot encode, and you will provide the sentence to it, and then we are printing the tokens. See, while printing the token, what I'm doing, encoded dot tokens, it will show the tokens. Now let's save it and run the script. See, the output we got is this. See guys, AGEN, this is one subword, TIC is another word. So even though our tokenizer don't have this agentic word in the vocabulary, but it handled it. It didn't give us unknown token over here. It gave us two tokens, AGEN and then TIC. How we got these tokens? Because our tokenizer, it is working well it is working well with this subword tokenization. It, during the training time, our tokenizer learned AGEN from various different words, like from agent, agency. During training, this tokenizer have seen tokens like agents or agent, and from there it learned, okay, we can divide it into two part, agent and the remaining part. And then this tick, TIC, from where our model or tokenizer learned this, because our vocabulary have words like robotic, it ends with TIC, and then there are words like semantic, then robotic. So from there our Subword tokenizer learned about these words. And guys, see, with Subword tokenization, even if the word which you are giving to your model, which you are giving to your tokenizer, is not present in the vocabulary, your uh, your tokenizer will handle it, because we have used subword tokenization. So now our tokenizer is working perfectly. We have trained the tokenizer on our domain specific dataset, and in my next video I'll show you how this tokenizer will be used with the transformer or with the LLM. So guys, I hope this video is helpful, and if you like my content, please like, share and subscribe my channel. Thank you for watching.